For this lab, or for this histogram, you were supposed to put 0 between intervals. Put 0 there, and use interval width of 0.1. Okay, so I'm not going to go all the way across this, so we'll put 0.1, 0.2, 0.3, 0.4. I'm just going to go to 0.5. I think that should cover everything. Negative 0.1, negative 0.2, negative 0.3, negative 0.4, and negative 0.5. Now, since there's so many zeros, I think what I'm going to do is just count them and put all the zeros in together, and then we'll do the rest of them. So if you count the zeros, I think there's 25. Is that right?
Yeah.
So I don't have 25 places to put 0. I've got 15 or 16. But I'm just going to leave the rest of them off. Just like if it was a number that was so far off the scale that it didn't fit on there, I would leave it off. Same thing if it goes up so far. If I wanted to show all that stuff, I could give you a bigger piece of graph paper. All right? That's not the point. You'll still be able to see the pattern here. So if we go all the way to the top, that should be 15 or 16 of the zeros. So just like that. And then let's go back and plot the other numbers. So the negative 0.35 right here. If you look at the way we've set this up, if this is 0 and this is 0.1, negative 0.1, this would be negative 0.05. Negative 0.15, negative 0.25, negative 0.35 would be right here on this boundary. If it's on the boundary, what's the rule? Which way does it go?
Falls to one side or the other.
Falls to the right. Always falls to the right, so it's going to go there. Then we get a positive 0.31. That's in between 0.25 and 0.35, so we're going to color in this one, or just outline that one. Then there's a negative 0.04. That's between negative 0.05 and positive 0.05. So it's going to go in the 0 one, but I don't have any room. So we'll leave that one off. A 0.15, which is going to be right here on this boundary, so it falls to the right. It's going to be there. And then a 0.14 is between 0.05 and 0.15, right there. And so let's put a title on it. Any histogram we do, or graph or whatever, should always have a title. So this is just going to be mass of ice and water. And you can tape it into that section of your comp book. So any questions about that? So let's go then to and again, some of you still need to send me your answers to the blue questions and to number 12 to make sure I get those sometime so you get your points. So let's talk about the lab we did yesterday, the mass of copper and sulfur. So blue question, the first blue question here has a total mass of copper and sulfur changed. Well, hopefully you're seeing a pattern in the labs that we're doing. Okay, in the mass of dissolved salt, the mass shouldn't have changed. In the mass of ice and water, the mass shouldn't change. In the mass of copper and sulfur, same thing. We had a sealed test tube, so nothing could come in, nothing could leave. And as long as that took place, you shouldn't have got any change in mass. So whether you did or you didn't put that it shouldn't change, I'm just going to say the total mass of copper and sulfur changed. No. Okay? And then do you think the substance in the bottom is sulfur, copper, or a new substance? It's a new substance. Number 13, it says the following data recorded in an experiment in which copper and sulfur were made to react. And so they give you a little bit more information than what we got because we're going to find a percent change, and this is the only way you can do it. But they give you the tube and the cover by themselves, so we can subtract that out later. Then they give you a mass before, then they give you a mass after, just like what we had. And so if you look at these questions, letter A on number 13 says what's the mass of the substance before the reaction? So I'm going to say 13A. 23.440 is the mass of everything minus the mass of the tube and the cover, 20.484. Anybody have that solved?
2.956.
2.956?
Yes.
Okay, 2.956 grams. And then letter B, what's the apparent change in mass of the reacting substances? So that's going to be the mass after minus the mass before, so 23.386 minus 23.440 gives you negative 0.054 grams, is that right? Okay. And then letter C, what's the apparent percent change in the mass of the reacting substances? So for percent change, we're going to take the change, negative 0.054 grams, divided by the mass of the substances we started with, 2.956 times 100, and you should get negative 1.8% for the percent change. Okay, so it lost 1.8% of its mass. That's all they're asking. Make sure you have the work for those two, don't just have the answers, okay? That way you can look at it later on and see how you got it. Number 14, this is a test tube containing 4 grams of iron and 2.4 grams of sulfur, was heated in a manner similar to that of the copper and sulfur experiment. Before heating, the total mass of the tube and the contents measured on the balance was 36.50. After heating, the mass was measured again. The mass of the tube and contents was 36.48 grams. Do you think it's reasonable that mass remained the same or was conserved during this experiment? What do you think? Is 0.02 grams enough to say that that's a change?
No.
Okay, here's what I'm going to say. Now here's some no's and some yeses. I'm going to say no. And the reason why, it's within the sensitivity of the balance. We said the sensitivity of the balance is 0.05. 0.02 is within that sensitivity. So I would say that that's not a big enough difference. And from what I know about the law of conservation of mass, which we'll get into later, I know that mass is conserved. Mass shouldn't change. Okay? Letter B says, what additional steps would you take to increase your confidence in your answer to part A? What could you do?
You could get a more accurate balance.
Okay, you could. What else could you do?
Do it again.
Mass again.
Do it again, okay? And not just mass again, I'd say do the whole experiment again. Okay, so I'm just gonna say repeat the experiment. And we could do that as many times as we need to. And then we could find at the end what the average was. And so if we get a whole bunch of positive changes and a whole bunch of negative changes, probably it's gonna end up somewhere close to 0. The more times we do it, the closer to 0 you're gonna get. All right, so I'm going to erase this, and let's look at what's on Canvas, which we've done some of it already. So, any announcements? Says discuss the mass of ice and water histogram, which we did. Discuss the mass of copper and sulfur lab. There's 2 quizzes for you to take on Canvas. There's a histogram quiz and a mass of ice and water quiz. And you also need to do the mass of copper and sulfur histogram. And the way you're going to do that, place 0 between intervals and use an interval width again of 0.1, just like we've done on all of them. And remember, the reason why we're using 0.1 is because that includes everything within the sensitivity of the balance in the 0 column. Okay, that's why we're using 0.1. And so let me show you a couple things. If you look on Canvas, if you look under the modules at the mass of ice and water, I attached the histogram that we just got done making. So if you need to go back and look at it, it's attached on there. All right? I also, in the mass of copper and sulfur lab, which it wasn't there yesterday, I just put it on this morning. I gave you the data, last year's class data for this lab too. So here's the class data. there's a change in mass, the changes in mass that you need to plot. And so I'll give you a piece of graph paper. So do the quizzes first, then go back and do this histogram. Some of you still need to send me your answers to those labs. I don't care if you just email them to me, or if you want to take a picture and send them to me that way. Make sure you can read the picture. Why?
All questions in there. Did we just do all the questions?
Yeah, I gave you all the answers to the questions, so send me, all I want's the questions.